Hello, statistics student. This video is for chapter 8.3, confidence interval for population proportion. The word proportion in statistics means percentage of a particular category of interest, and in binomial, we call the one that we are counting with a particular characteristics, we call it the success, right? So the number of success in a population. Example would be you want to find out what is the percentage of students that are transfer students in a community college. There are a lot of people go to community college to get other things, maybe just for to get an AA degree, but not transfer, or for occupational training for certificate or whatever. So this is all of the population, right? So if you are to count everyone in the population of this college, you would be able to count whoever that is a transfer student. So that would be the X number out of N number in the population. So that is a proportion, population proportion if you count everyone. But of course, it's very difficult to count unless you are the registrar in the college. So if we want to estimate that, we can collect a sample, right? So we take this one sample here. Then out of these samples, this sample could be big, could be 200-300 students. And out of this, well, of course, they need to be randomly collected. Sample size is small n. We also count X, right? But X is whatever that you're counting. You say, okay, I want to count the transfer students percentage. So X over N would be the sample proportion. Now, to distinguish it from the population proportion, where you count from everyone in the population, we call it p hat. But this is actually just a decimal notation of a percent. So when you write it out, you will say, oh, okay, 20% are transfer students or 30% are transfer student, like that. So you use this p hat to estimate p. Okay, so the way you estimate, we call it a point estimate. It's just one number based on one sample. So we call this X is the number of success, N is the sample size. So basically, you're counting something. When you heard of this, did you remember that when you do binomial distribution, you are doing the same thing? You're counting something out of N, right? Of course, for binomial, it has to obey like independence and two outcomes and etc. So we were going to use the behavior of binomial distribution of X to understand how this p hat behave. Because just like before when we have mean, we like to know how this one sample p hat differ from the real one by thinking of, well, can I do a confidence interval by saying p hat plus and minus a e? Now, in the mean 8.1 and 8.2 situation, we know what E is, right? E is how X bar spread out. And we know X bar is spread out by central limit theorem normally. But how does this P hat spread out? Right? It is not, it's just X over N of of a sample out of a population. So because it's closely related to binomial, just let's look at it. Now, before we do that, let's look at all the symbols and terms related to confidence interval for population proportion. Mainly, if I have a sample, I calculate a proportion of interest that I want to find out, like percentage of something. And then I want to use this to find out what is the error bound. And so to get a confidence interval of the real P should be in this range. So we still have, so P hat is X over N, where X is number of success, N is sample size, C level is what is all the X that's supposed to occur by chance. So the X number would vary, but I should be able to see those that are likely to happen by chance. That's C level. The default is 95% because we think that by default 5% is unlikely to happen by chance. So alpha is significant level, which is unlikely probability value, is 1 minus C level. And usually C level is those that's most likely to occur in the middle. Error bound would be how far away this P hat from P. Okay, so we need to know how does P hat distribute. P has distribution. We know P. We know um, distribute. distribution. So that means when I graph p hat, if I collect a lot of p hat and I graph it in like a number line, is it normal? Because in the old days, x bar is always normal, right? What kind of distribution do I have? P hat. So if I know that, then I can calculate the error bound. So the approach to do it is think of x. X is modeled by binomial, and x has a mean of NP. Sigma is square root NPQ. So we know we can calculate the mean of x. So x binomial distribution is what is the probability of x, right? So the distribution p hat will have mean. P hat is x over n. So you would divide this by n. You divide this by n. It would turns out that the mean of p hat will be the real p, and the standard deviation will be square root of pq over n. Whereas what is q? Q is the probability of failure, not successful. Okay. So if we look at a lot of p hat, you will notice that, look at a lot of binomial distribution of x. We notice that actually they are normally distributed. And I will show you the graph of, the graph of x binomial distribution in class. So, so you would see that p hat, because x is normally distributed, all these x is normally distributed. You have different x from different sample. They're normally distributed with the mean of NP. So p hat will be normally distributed with the mean of p. Okay, and this only work if NP and NQ is at least 5. That means x and n minus x is at least 5 in this case. So if your number of success and number of failure in a sample where you collect them is at least 5, yet success and failure are both at least 5, then p hat will be normally distributed, right? If it is normally distributed, we can use the fact that S standard deviation is equal to square root of pq over n to find the error. The error would be z alpha over 2 square root of pq over n. Now, PQ is something that we don't know because we're trying to estimate P. So we would use P hat and Q hat to replace PQ. So this is like the tick mark for each of the normal distribution of P hat. And then the error would be Z alpha over 2 square root of P hat Q hat over N. Okay, remember Q hat is P hat is X over N and Q hat is 1 minus P hat. So here, this is the summary of what we talk about. It's all based on the fact that x can be normally distributed by looking at graph of how x behave under the criteria of x is greater than 5, n minus x is greater than 5. Interval estimate would be p hat minus e, p hat plus e, because we have the plus and minus notation of, if you want to estimate p, it would be p hat plus and minus e, this range, where e is z alpha over 2 square root of p hat q hat over n. So the formula is quite complicated. You need to find the critical value p alpha over 2, which is the tail with sea level in between, right? P hat is x over n, q hat is 1 minus p, n is sample size. So this, again, I say the requirement. The requirement is when x and n minus x is greater than or equal to 5. How do I find the critical value? It's the same as when we're doing mean. You put sea level in the middle, and you say between that high positive number would be the critical value. Or you can find alpha over 2, which is 1 minus sea level divided by 2, and you find above with that area. So let's do one confidence interval by using that formula. Let's say I have a sample size of 200, a 200 student. Out of the 200, X is 82. Maybe 82 are transfer students. Well, let's construct a 90% confidence interval of the population proportion P. Okay, so we want to find out for real, what is the percentage of P In this case, in this particular sample, p hat is 82 over 200, right? And we cannot find p because that's involved counting everyone in the population. So 82 over 200 in decimal is 0.41. Q hat would be 1 minus 0.41. That means it's not whatever that I'm counting. So 41. 1 minus 0.41, that would be 0.59. So we get that. Let's find the critical value. Critical value is based on sea level. Equal to 90. And you should know it because it's Z. We use inverse normal, having in between 0.90. Is it 0.90? Yeah, 0.90. So I already calculated. It's 1.645. So this number with half of a tail at the right side is 1.645. That means at maximum, the p hat that you find would be 1.645 times of standard deviation away from p. So 1.645. So now we are ready to calculate it. Margin of error E is 1.645 for 90%, right? Square root of 0.41 times 0.59 over 200. N is 200. And, okay, so put in the calculator 1.645 times square root of 0.41 times 0.59 divided by 200. So I got 0.0572. Usually for decimal places, 0.0572. So that means how far away is this p hat from p? The maximum is just 0.0572 because each tick mark is p hat q hat over n. Confidence interval would be, we have three format. The first format, of course, is a plus and minus one, would be 0.41 p hat plus and minus e, right? So we say p is in this range, p hat 0.41 plus and minus 0.0572. So that is the notation. So that means my sample is 41%, but it would be backward of 5.7% or forward of 5.7%. So the second is what is the actual exact range? So will be P is equal to 0.41, actually minus 0.0572, 0.353. So round to three places, 0.353. And add, right, 0.41, add 0.0572, 0.467. 0.467. So these are three places. This is four places. And of course, we can also do the interval notation. Just do 0.353 all the way, comma, to 0.467. That means this particular sample show us is 41%. I don't know if it's transfer student that's that many, but the real proportion, the real percentage could be 35.3 up to 46.7. So that's how you interpret it. Okay. Of course, you don't have to do hand calculation. You can do online calculator, and it's this. So let me show you how to do it, and then we'll do the example in the second video. So you do analysis, confidence interval, proportion one sample, the first one, proportion one sample. And you write down, you do your sea level, sample size n, and number of success x. And you evaluate and you will get the answer. Again, they have the margin of error. Now they do give you two confidence interval. We use the using normal approximation one because we are actually approximating binomial as normal distribution and use this method to calculate. The Wilson score confidence interval is one that's supposed to be more accurate, but you can read your book or Google to find out what's the difference. There's a little difference in terms of modeling binomial, and in some cases this is more accurate. So that's how you do it. There is no data; it's only sea level n and x. Okay.